Hello, hello. Anybody there? Welcome. Hi, Gerardo. Welcome. I'm just gonna wait a few minutes here to see if people will tune in, and then we can get started. So yeah, it's Valentine's Day. I'm taking a Valentine's Day stream today. Yeah, we just found it a good day to go online, say hi, and we'll go through several guides about this new website that we put together for Wilderness Labs. I'm Jorge, by the way, developer advocate, and I also have some exciting new getting started guides to walk you through a few of them so you can take a look and get a gist of how you can set up your IoT devices using .NET in several places. Yeah, so I have here a video camera feed, and I'm showing here a project lab, but I have several other hardwares that I'd like to show today. I also have here a Raspberry Pi that is running a Meadow application, and I also have a reTerminal by Seed Studio. Let me fix the camera here. Yeah, C Studio is like another Raspberry Pi, but it has a built-in monitor and a few buttons, and has the pinouts here. It's also pretty cool, so you can make easy HMI on the go. We can also run Meadow on that hardware as well. I also have a core compute dev kit, so I 3D printed this board so I can have a breadboard half size next to it so I can connect stuff. In that case, I have a display. And extra exercise, I want to see if I have enough time to show you how easy you can write. You can configure that screen so you can show hello world messages on each platform. You can see it's basically the same code running in several different hardware configurations. So without further ado, let's just jump in. I'm going to zoom in a bit, and let me show my screen. And so welcome to the stream again. As some of you may have known me or not, my name is Jorge, and I'm going to walk you through a little bit about our new website. And as you can see here, we have revamped it with some cool illustrations, kind of Mandalorian kind of feel. And we also have sections for the new pricing strategy. We have a free tier for development that is more than capable of, having up to 25 devices you can set up to Meadow Cloud, so you can orchestrate all your devices from anywhere up to the point. I think it's a good starting point, so you can get familiar with all the technology with no constraints about 25 devices is more than enough, and you can do things like health monitoring. You can do over-the-air updates, device logs, enterprise integration, 10,000 integration transactions per month. So Meadow Cloud has integrations to Azure and using webhooks and all that. So you can set up your prototyping or your enterprise, proof of concept, and you can plug in your integration Meadow Cloud, so you can put data coming in from there onto your dashboards. And we also have email and chat. We also have a free. We have a community public Slack that you can join. We have about just over 1,000 users there, and they're always willing to help, but also show and tell different projects they've been working on. We also have our shop here, so all the different goodies that we have on store. We have our IoT accelerators, Project Lab, GNSS Tracker, the Klima, and the regular of the mail Meadow F7 Feather, along with a hack kit and the core compute dev kit as well. And this is where the fun begins in the documentation. So we have revamped our documentation site, and this is going through. There's like a lot of improvements I've been doing. A nice one that I really enjoy, especially when you're coding in the dark, is we have dark theme. We're now modern and hip that we have dark theme now on our website, which is pretty cool. And so there's different breakdowns of getting started and introduction things for Meadow Foundation, Meadow OS fundamentals, and lots of also Meadow Cloud material to get you started. And we also here have a little shout out to Hackster with our bunch of projects that we've built over the years. And so there's just a few of them here. But there's plenty of material here that you can just check it out and get familiar with our platform. And the majority are with a Feather dev kit. So that one is a good starting point. It's the one that gives you most flexibility in writing your hardware applications, though Project Lab is pretty sweet as well. It's a little pricier, but it's just a powerhouse of sensors and a display built in. So no fuzz about plugging things on breadboards. It's all just out of the box and ready to write your own applications. And we also have the famous Getting Started page. This is why we're here. And if we go to the F7, for example, the F7 Feather, this is our Meadow Feather form factor. And as you can see on the left, we have getting started for several platforms. We have for the F7 Feather, we have for the core compute dev kit, we have a Project Lab one, and for single board computers, i.e., we have a Raspberry Pi, we have a reTerminal as well, and we have Jetson Nano. But the possibilities of more devices are you can try them out as well. It's all very agnostic, so it'll be able to run on any Linux embedded machine. And we also have Meadow Windows here. So even if you don't have a Meadow device right now, you can also try to get familiar of how you can use our Meadow software stack using just your Windows machine, which is pretty sweet. I use it a lot to build the HMI screens because development cycles are really fast. I think I made a YouTube video about that. And also, if you have you want to try hardware as well, you can use one of the Adafruit's FT232. It's an I/O expander that connects via USB-C, and then you can start plugging in their devices. Peripheral sensors, LEDs, and then you can even screens, and then you can start building hardware using just your Windows machine before diving into Meadow. So without further ado, let's go with I'll go and just about the F7. I think we've covered that one several times. I think we should just go into the Raspberry Pi first, and then we can take it from there. But notice that all our platform, or all our getting started guides has Visual Studio 2022 route and Visual Studio Code route as well. So we support both IDEs. Very important if you're also a Mac user, a Linux user, that you won't be able to have Visual Studio full 2022 installed. So you can just make do with Visual Studio Code, which I think is pretty capable now. And the first things that you'll need to install will be the .NET runtime. So it works with the latest version of .NET. You'll need that to install. Next step, we'll need to install the Visual Studio Code. And then we have extensions for both Visual Studio and VS Code. So you'll need that in order to communicate with your Meadow devices as well. And this enables also things like debugging, and you can also set different configuration builds and and then you also need to install the Wilderness Meadow template NuGet package. So it's a package that's been around for a while, but we updated it so we include even more Meadow project templates here. So if you open a console, let me open one right now, and you do .NET new, I think I can actually copy this. It says install. I have already installed, but it's reinstalling it. But then, as you can see, once installed, you have a slew of lots of more templates readily available here. So we have the standard core compute module application. And for these, we also support F# and Visual VB.NET. And the same goes for the F7 Feather. We have the general Meadow library, which is like the lifeblood of Meadow Foundation. We make drivers to make users, to make hardware be plug and play into our projects. We also have a Project Lab app, which I think it was important. It was time to include a demo app here, especially for those who buy a Project Lab to get out of the box and like, we get started. We always send them to the GitHub repo that had a demo app, but I think it makes more sense to have a diagnostics demo app. And so we can start with that one so you can take a look how it looks. Basically, it runs a diagnostics application that will go through all the different sensors, and that will give you a look about how everything is plugged together. And we dive into the code, you see how everything is, how you use an IoT accelerator like Project Lab. And we also have the Meadow Linux applications. We have the one for Raspberry Pi, one for reTerminal, and one for Jetson Nano, which are the boards that we have on hand, but we can add more at features request or by popular demand. And we also have the Meadow Windows application templates, one for WinForms with the FT232 and one with just WinForms, which is just for simulation and HMI screen building. Oh, I see Brian in the chat. Hello. And I see more people here. Welcome. All right. I'm going to jump in and let's start with Project Lab. Let's try something fun here. So say we have, let me move this out of the way. So I have my Project Lab here. And the first thing that you'll need to do is obviously, again, going through all the steps, you'll need the .NET runtime installed. You'll need the Visual Studio installed, obviously. Latest, the community version will work. And we also have the VS 2022 tools for Meadow. So that is our extension that we use to deploy apps into our Meadow powered devices. And so there is a day one update when you get your device. So you'll need to deploy latest version available of the Meadow OS. So for that, we use a tool, a command line tool called Meadow CLI. So there are some steps here that it'll walk you through how you can get started on using the Meadow CLI. And once you do that, you can start downloading the OX extension. So if you do just Meadow out of the box, it'll give you a list of all the commands that are available here. So I'm running the version 2.05, and then this is the CLI version 2 that just came out recently. So we did a few changes, a few tweaks on the command. So there's some that the V1 folk might know already, but they're deprecated because we want to align a convention for all these commands to make them more intuitive. So these will slowly be going away, and then we'll stick to the new ones. These are the runtime ones that you will need, and we also have firmware commands for OS writing. So if we do firmware download, let me write it here real quick. Firmware download, and that is going to go and download the latest binaries. In that case, I already have it. For this latest version of the CLI, you'll need a Wilderness Labs account. So make sure you create your account, and then it'll try to authenticate when you try this command. And if you haven't logged in, it'll pop up a web browser. Once you log in, it says authentication successful, and then you can try again the command, and it'll download your firmware. And then finally, when you do firmware.write, that would be the command that you use to flash your Meadow application, your Meadow device. Just a bit of that, but then let's create our first application. So here, as you can see, when we install the new the Visual Studio extension for Meadow, it's going to also install all the different templates that I showed you earlier today. So I have the Visual Studio open, so let's add a new project here. And I have already, but I can show you if you do Meadow here. And don't hesitate to ask any questions. I'm kind of alert here for incoming comments, and I can answer as soon as I can. So yeah, feel free, don't be shy. I see 15 people here, and so welcome. So let's go to the Meadow Project Lab app template. And let's do hello Project Lab. Okay, so let's create this project. Yeah, it was a lot of time coming getting all these templates together, but I think it paid off. It's much easier to use and get you started real quick of how, because we on show and tell a public Slack, we would show things that we were working on and like, how do you get this to work? And so there was like enough of us trying to share code to get you started, and especially in other platforms. So it's cool that we're getting there. We're getting there to get you started even faster when using Meadow in other platforms such as Raspberry Pi, which I think is a very popular board. And yeah, so this is the Hello Project Lab project that I just created. And notice that here it has a couple of NuGet packages. One is for the Project Lab itself, has its own library. And if we go to the Meadow app, we also have a set of commands that will give you just an understanding of how you can use the Project Lab. So we have a Project Lab create. This creates an object, and then you have access to all the different peripherals that the Project Lab offers. So we have a display, we have a down button, we have Grove connectors, microbus connectors, light sensor, motion sensors, a lot of stuff happening on this board. And so we access on each one of them, and we start a display controller, and this is what it'll activate the display and start drawing all the peripherals built in Oh, pardon me about the noise. I'm very close to a very busy street. There goes an ambulance. Okay, thank you. So yes, so we have light sensor, atmospheric sensor, accelerometer, or gyroscope. And then here we have the start updating commands. All this is already available. I mean, again, it's a template, so you can create it and you can take a look yourself how this thing is put together. The display controller, it's just a abstraction to have. Oh, while I'm talking and going through all of this, why won't I just deploy this? Because this will take a bit of time. So hold on for a second. I'm going to plug in my board. There we go. And so with the Visual Studio extension, I can select my COM port here. There we go. And then I am going to just deploy. And that will take a bit. For the first deployment on your Meta applications, it will take a while because it's going to download, it's going to transfer all the necessary files in order for the application to run. But then the extension it's smart enough that whenever you do subsequent changes on your code, it'll only deploy what files you change. So development cycles go much faster. So as I was saying, we have display controller here, and we have micrographics is our in-house graphics library that it draws. It's display agnostic. Notice that it receives just an iGraphics display, so any kinds of displays it'll work as long as it's pixel. And obviously, not you can't put a character 7-digit displays there; it won't draw things. And then it'll do things like graphics clear, and then it'll do a draw method, and then finally graphics.show, which is just emptying the buffer into the display so we can see any changes. And then here are some primitives for draw text, which is what we're doing with everything here to show all these values for sensors and button states as well into the display. All this is also open source. So while we wait for that to transfer, let me refer you to our, we have a GitHub Wilderness Labs org space here, and we'll have all different repos. The ones that you should look out for are the project lab here. And if you look here, we have all the specifications of what's everything that is built in as well. There's also schematics, and there's also enclosures as well. So you can print these, though if you buy one now, they come with a carbon fiber, I think. I think it's carbon fiber PLA. It's like ultra durable one. And so it's in case you like to have a spare or something, you can also print it yourself. And demos, we have lots of demos available as well. So we have demos for Project Lab, and we have for Project Lab, and for F7, we have for Juego as well. So so make sure that you head over to our GitHub space and check us there, all the different content that we have. Let's see how looks like this finished transferring. So this should turn on any minute now. Okay, health metrics disable is starting the hardware. It detected is a Project Lab v3. And it's going to start writing anytime now. Oh, it even has a speaker there. I forgot about that. Let me zoom in. And let me put this in the solo mode. So here we go. We have Project Lab right out of the box. So you get one, you can just build a template and you just run it, and then you'll be able to see your Project Lab running with all the different sensors values here as well. So 26 degrees Celsius and pressure, humidity, all that sort of fun stuff. Let's get this one out of the solo mode. That's one that I wanted to show you. Let's do one thing real fast. Because I've been wanting to show you how you can write things, how you can write hello worlds really easily. So let's just do that one real quick. I have some cheat code here because I don't want to live code too much. So if I want to, I'm going to replace this display controller here. Now there's a lot of stuff happening here, but I am going to just replace it with this. Now this is using something called micro layouts. It's another in-house library that we've built that is for building HMI screens. It's like a UI building framework. So rather than using graphics and the old-fashioned way, drawing text and drawing values, drawing shapes like you would do in a video game, this one's a lot more smarter to make and easier to make UI screens. So you think of it as an absolute layout. So we have a display screen, and every display screen has, I don't need that extra using, thank you very much. And so think of it as an absolute layout. So you create a display screen passing you pass on a display that is past a 9 graphics display, and that one will start a screen that is full size according to your resolutions, and then you can access a list of controls. In this case, I have a new label, and the label is, you can specify it would be the coordinates for X and Y, which is left and top, and the width and height of how big this label is going to occupy. In this case, I made it from 0 to 0 and take the entire screen, take the space of the entire screen, and I have a message here saying hello world. And we also do things like alignments. So I wanted to have it front and center of the display. So even though the label is taking up the entire space of the screen, it's just going to show a message, hello world message on the middle, on the center. And we also have different font sizes as well. So I have a font 12 by 20, and there's as small as 6 by 8 for very small screens. So if I run this, let me see if oh yes, I need to clean all that stuff as well. Hold on. In this case, I'm not going to use any of those sensors, except we're going to just use the display as well. So I'm doing project lab create display controller, and I pass in the display. So if I do that, just run and deploy this thing. It's going to be faster. Where am I at? Okay, 28 minutes in. Yeah, I was testing. I have a similar code as well for a Raspberry Pi and connecting via VNC. I am not sure why it's taking so long. But we'll make the best of it. With reTerminal, though, I can use something called a Linux debugger. So it's an extension, and so it helps me that I can build applications from my Visual Studio, and it'll build and deploy over the network into the reTerminal. So I just need to go over there and then just simply run the application. So no need to actually code in the device, because I think sometimes that's a little tedious. And let's see, this thing should be running now. Instantiating. Okay, creating all the things. And there we go. We have the hello message that I wanted. Hello world. Cool. So that's all it took. I create a project lab object, and then I pass it into my display controller. And my display controller is just a class that just receives a display of type iGraphics display. And based off of that, I can just go ahead and start building my screen without even knowing what kind of screen I'm using. It'll just do it. So let's move on to the next one. I think I'm taking a little bit of more time. Let's unplug this one. And this one is a fun one. I'm going to use my my Core Compute Dev Kit. I have it right here. It's a big boy. So we have different add-ons for this. This is the Core Compute. This is Meadow. The one that you know is the feather form factor, but then this one is the surface mount version. So you can just embed it onto, when you go to production, you make your custom PCBs. This is the little guy that goes on board. So you no longer, it's even a smaller size one. I think it's the size of a coin. But anyways, let me just connect this here. Okay, and then, all right. So let's do another project sample here. So again, this one would be, if we go to our website, let me close all these. This will be the Hello CCM Dev Kit, which is this guy here. And this is the same root. You will still need the .NET Runtime, Visual Studio, VS extension, day one update for Meadow OS, just like you would do for F7 Feather. And then you create your first Meadow application. We have an incoming message. Oh, no, thank you. I don't know if I can cancel that. So you can create a new project template, which is Core Compute. And then let's start with that. So if I go here, add new project, Core Compute, next. And I do Hello CCM, create. Cool. And since this doesn't have any peripherals noticeable to show anything, right now it's just going to show you just a couple strings. But that's just out of the gates. Let's just get this working. Notice here, I'm already cheating because I already have the sensor working. I mean, the display working here, but I'll recreate it here right now. So what we'll need here is we'll need your standard, that same display controller class that I showed you before. I think the only variation that I have in these cases are the orientation, because sometimes, well, in this case, this screen is upside down compared to the one I showed you on the project lab. Oh, right. I also need to add I also need to add the micro layout. So if we go to the NuGet package stuff here, we do Meadow micro layout. And then we add it here. I'm not going to use the beta one. Did it add it? No. Oh, I did. Dang it. Okay. Install. Okay, now I think it did. Okay. Cool. And here I'm going to add micro layouts. And this reflection I made that Visual Studio just likes to add it by itself. Oh, and according to color reference, using Meadow as well, we have our own color category here. And for the Meadow application, we just need to do this. I'm just going to copy the initialize. Oh, we need to add another NuGet package. This one would be for the display. This is an ST7789. And it comes with the hack kit that I showed you earlier. So if you have a hack kit laying around, this is a 240 by 240 pixel display connected via SPI. So once we add that NuGet package, adding the references, and you're all good to go. So here I'm specifying, I'm creating a display object. So I'm passing the display bus. So I got a couple of, these are the, let me go in detail here. Where's my, okay, here I am. And so I'm creating these two yellow lines are the SPI bus, and these two are other for data for the chip select and the reset pins. They're just pins that are needed for this display in order to work. And we're also specifying 240 by 240 resolution because there are different variations of the display that are using the same controller. And when we do that, we're passing that display, we're passing into our display controller, which also does pretty much what I showed you on the Project Lab example as well. Just creates a display screen and then just creates a hello world in the middle. So let's just reset the board. And this should pick it up here. Now it's the conf4. There we go. And deploy. This one's going to take a while, but so yeah, the principle of all this is Meadow is fairly simple to write your Meadow applications. Note that the ST, I didn't need to write any drivers. I didn't need to know the ins and outs of how to make the display work. We're just a NuGet package away that you just add into your project. You specify to which pins are connected, and then now you can just use it, which I think is pretty powerful. And you'll see it running on this display, on this board, and virtually like we also have this class that is practically the same as the one that I showed you on the Project Lab. They're very similar, so just by doing a few tweaks, you can get this to run practically anywhere. I think I want to speed things up, but if you can see here, if I go to solo mode, you can see that this is was already running. Oh, I think I moved it. This breadboard's not very good. But then that one will also show a hello world message on this display. But I want to go a little bit faster now. So let's just leave that one be for now and move on to the one that I think people will like to see in action. And I have here a Raspberry Pi. So for Raspberry Pi, it's a little different than using just our Meadow hardware. So if we go here, and you can go in through this blog post of how to build your application and how to set up your Raspberry Pi. So again, you'll need to, if you go to this blog post, it'll show you how the best way to install .NET runtime and get you started on setting up all your .NET stuff on your Raspberry Pi. So it gives you this command, which has like a script, and it'll try to install everything for you instead of you trying to go and start doing a combo of commands. This will all do it by itself. And then inside once inside you do the remote connection on it, and then you can install Visual Studio Code, and you can start writing your applications right inside your Raspberry Pi. So same deal, you'll need to install the Wilderness Lab Meadow template to add all these templates on your machine. And then when you do .NET New Raspberry Pi, is going to create a little project demo. So let me open VNC here. See how it behaves, because I don't know why my VNC is so slow lately. I have already something running here. Okay. Okay. So I have this one already built, but let me see. I'll start. Okay, let me see. I do this. Let's close this folder. And let's start a terminal. Okay, so I do .NET New. I already installed the template, so I don't think I need to install it again. So I do .NET New Raspberry Pi, and then you pass an end parameter to show to name your project. So .NET New Raspberry Pi. Yeah, this thing is slow. Yeah, it's gonna take a while if I go at this rate. I'll just show you one created, and then I can go on the other one that has already the Hello World project running, and then I'll show you that, so we don't lose time here. Yeah, I realized this. I don't know why my VNC thing is very slow. Okay, .NET New, Raspberry Pi. So when you do that, in theory, you should create a new Raspberry project called Hello World. So if I do cd Hello World, you go here, and then also in your Visual Studio Code, open folder, and then you have your Hello World here open. And this is what a Raspberry Pi template project looks like. There isn't much here. This is very similar to the one that we have on the Core Compute dev kit. Notice that on the signature of the Meadow application, which is our main class for these Meadow apps, we're also defining what kind of device we're running. So in this case, we have a Meadow Linux application, and we also pass in the form factor or the hardware that we're planning on running this Meadow Linux app. In this case, is a Raspberry Pi. Why do we do that? Because we need to specify the device so we have access to all its pins once we start plugging things into the device. So once you have your Meadow application running here, you can do, let's go to the terminal again. And we do .NET build. .NET build. Oh, yes. Thank you, Richard. I forgot to remove the solo mode. Sorry about that, guys. Yeah. Yeah, I should have captured that. Let me actually zoom in here. Full screen on. Okay. Yeah, let me catch you up with what I have here. Sorry about that. I did a VNC connection to the Raspberry Pi so I can remote in. And so this right now, what I have here is the Raspberry Pi that I'm inside. and I have a Visual Studio Code running, and I did a .NET GNU Raspberry Pi to create a Raspberry Pi project, and this is what it created. And I was saying that this is a Metal Linux device, right? So a Metal Linux project. So you're specifying in what platform this is running and what kind of device we're using to run this application. In this case, this is a Raspberry Pi. So this is important. So when you do device.pins, you have all access to all the pins, and you can start wiring things up really easily. So if I do .NET build, this will use .NET Runtime to build your application. At least running and building itself, the project is much faster, obviously, because the Raspberry Pi is a very powerful computer. Like, it's a single board computer. So if you do .NET run now, my connection remoting in is not fast. I don't know why. I think I might need to try Ethernet next time. And then if I do that, .NET run, this is initializing the OS. And then here we have all the 3 strings that are on our application. We have an initialize, we have a run string, and then finally a hello Raspberry Pi. If you see all those, then you're good to go. You have successfully configured your setup for Raspberry Pi. I'm going to open one because I don't want to code here for too long. It takes a while. File. I think it was Cool Demo, the one that I wanted to show. Yes, that's the one. Perfect. So this is the other one that I want to show you about running the same ST7789 240 by 240 display. I also wanted to run it on a Metal Linux device. So here we're instantiating an SPI bus. It's slightly different than what we have on the Metal hardware. And we also need to specify a few other things like configuration, clock configuration. But then here in the display, we're newing it up, just passing in that SPI object. And also notice important here is we're specifying which pins are connected for the data lines, for DC pin or reset pin. These are some extra pins that you need to connect to your device. And also specifying here resolution. But then when you pass all that to the display controller, same class that I've shown you before, it'll just start a full screen, blue full screen that says a hello world message here. So if I go there, let's go to terminal. All right, so I need to, cool demo. Okay, so it already opened the one that I wanted, .NET build. So as it's a Metal Linux device, we also take a look at the NuGet packages that are installed in this type of project. So the template will include a Metal Linux NuGet package, and we also have a Meta Foundation built in as well in case you start building simple things. You already will have access to that, but if you're going for more specialized peripherals, such as the little display there, you'll need to add it. You need to add them separately. So there's a TFT SPI that has a family of displays, and we also have the micro layouts, that library that we use to make to show UI using the new UI framework library. So once it's built, I do .NET. Type wrong. .NET run. And let me remove full screen layouts. So this initializing, and then this just runs the solo mode. And then there you go. It has initialized run hello Raspberry Pi, and you have that hello world message here on the screen. Yay. Okay, cool. So that's the gist of how Meadow Linux works. So there's a template already you can see, and then it'll just, you can either remote in, or you can also use, there's also a what's it called, the remote tunnel access with Visual Studio Code, but it hasn't worked very reliable to me, so I didn't want to demo it. But what that does is you have a Visual Studio Code on your Windows machine or Mac, and then it'll establish a remote tunnel connection to your Raspberry Pi, and so it'll mirror the environments, so you can code and write your project on Visual Studio on your development machine, but then you use a command and it'll run everything remotely onto the Raspberry Pi. I haven't been successful to get this to work very reliably, so I'll need to keep out for updates to make sure that it works, so I can properly document this. So let me fall back here. There we go. Okay, so let's go to another demo here. I'm gonna disconnect this. Oh, I should turn it off properly, don't I? I don't want to kill it, so log out. Shut this down. Let's do reTerminal, and then I will end with WinForms template, which is also pretty simple and also fast to build. Let's see. Shut down. Okay, I'm gonna have to hard stop this thing. Okay. So I have a reTerminal now by Seed Studio. Let me see if I can put it here. There we go. Oh, this is giving me a lot of glare. Bear with me. I think I'm going to have to print this. Okay, cool. There is my reTerminal. So I can also remote in. Come on, you can do it. There you go. Cool. Thank you. Yeah, it seems like the Raspberry Pi is slow. I think the reTerminal is doing a better job. Okay, so open a terminal here. And so back into our getting started documentation, that's why we're here. There's a hello reTerminal section on our docs. So you can open this, and it also gives you the walkthrough of how you can set up your reTerminal for Meadow applications. The reTerminal is basically just a Raspberry Pi and an enclosure that has some buttons, and it has this very nice display. I think it's 720 by 1280, if I'm not mistaken, or 1280 by 720. So it's very tiny to read, but hey, it's a display, so you can see what's happening and inside. So it's pretty sweet. And again, you can also install Visual Studio Code. That same blog post that I mentioned for setting up your Raspberry Pi works the same. And then you need to add .new install, and that will install all your templates. Here are all the slew of templates here, and then we have one that is the reTerminal. So let's create a new project there. So let's go into here, and I think I can actually full screen this, so I can. There we go. Now let's do .NET new terminal -n, and I do hello. Now this template is this thing, did it work? Oh, I think I did. I need to install the templates. I haven't done this in a while. .NET new install. Yeah, these things are very temperamental with sometimes I need to restart. There we go. So .NET new install. There we go. Wilderness Labs, Meadow 8. Oh, there we go. Yeah, I was out of date. So I do that, and now I do .NET new. Yep. reTerminal. And I do hello reTerminal. Let's do that. Cool. Now if I do cd hello, I need to go into my project that I just created, sorry. And let's go to a file. Let's open that folder here on Visual Studio. Open. And then here, since reTerminal already has a display built in, it's something that we added a little bit of more finesse or something cooler to show on this template project. So in this case, we have a GTK display, and it's a virtual. It's like a virtual display, I guess, or like a window that we can show onto any Linux devices. You'll need to make sure that you have GTK installed. Think of it as like Linux WinForms version. For Windows, we have WinForms. For Linux, we can use GTK. So that way, you don't need to plug in any display in this case. You'll just use a virtual display that is already. It'll just show on the desktop of the Raspberry Pi itself. Require assets? No, I don't think so. Okay, so basically, this is very similar to what I've shown you. So I'm creating a GTK display. I'm passing in some parameters about color modes and what resolutions. This is 320 by 240, which is the same dimensions that the Project Labs display has. And then we pass that into a display controller. And the display controller is very similar to what I've shown you before. This one already has the macro layouts here built in. And it creates, that blue full screen color, and it has a hello world message. Actually, let's do hello comma world. I think that's the standard. And let's take a look at the NuGet packages. So again, we have Meadow Linux here with Meadow Foundation. And as for the display that we're using GTK, then we do Meadow Foundation displays GTK here. And finally, the micro layouts so we can display labels. So if I go back into the terminal, where is that terminal? View. There you are. Okay. So let's do .NET build. And that's going to build our application. And no errors. A couple warnings. That's okay. .NET run. Now we're gonna see a little window showing up in the middle of the screen here. And there we go. We have a hello world message. Cool. I think we're working, or I think Chris is working to add a window here so we can drag it around, because right now we can't. we can move this around. It's just there. So if you go full screen, then make sure you do Alt Tab to go somewhere else. You do Control C on the terminal to stop it. Yeah, we're working on that. But yeah, I think that's the gist of it. Notice that the Hello World was bigger because we also support scale factor. So if you're in a very high res display, we don't want pixel perfect fonts. We want to make them actually bigger so they're more readable. So in this case, we use a scale factor of 2, and I think it goes up to 5 if you want to make things really, really big. So if I remove the scale factor, .NET Build. Oh, any comments here? Oh, yeah, there's Hausen there. Thanks, Hausen. And then we do .NET Run. .NET Run. And then that will be the pixel perfect one that will show a 12 by 20 font. So yeah, there is another Hello World message there from another hardware. Notice that it's also pretty similar of what we have. It's actually pretty much the same what we had besides from the rotation, because sometimes I rotate the screen. So there's a rotation parameter here that you can add to. Yeah, here we go, rotation types. Oh, I got IntelliSense here, I forgot. So yeah, we can do normal and then 90, 180, 270. So you can put it in whatever rotation you want. This case, I didn't need to. So that is it for reTerminal. Let me go off script here because I want to try something that I didn't have time to try before the demo, but I want to give it a try anyways. I have this Linux debugger extension, and so you can build and deploy. Let me see if I have it properly built. .NET. Yes, debugger, okay. Configured. I'm going to create a reTerminal project here. Am I showing this right? Yes, okay, cool. So I'm going to do Meadow. And there should be a reTerminal one here. Jetson, no, Raspberry Pi, reTerminal, here we go. Next, I do hello reTerminal. Let's do reTerminal. So as I mentioned before, this Linux debugger is really cool because you're here at home in Visual Studio 2022, and you can build your application just like you would be working on just here Windows, and then you can select, set up a rebuild this. I don't think I need to build it because I think the Linux debugger will do it. If I do extensions, Linux debugger, build and deploy, see if this will work. I probably don't have it. I think I don't have it configured for this demo. I think I have to set it up properly. But this is really cool because what you do is you build an application on your Visual Studio, then you do build and deploy, and this will build your application using your Windows machine, and it'll just send the application assemblies onto your target device. So that way, you just need to remote in and do .NET Run to run the application. So that will save you time of actually just hanging out on your little display on the Raspberry Pi, and so it makes things really fast. So if you go to the Visual Studio route on the getting started section, I mentioned about this via the Linux debugger. So if you go here, it's open source. It's been in the making. They're trying to get debug work as well, so you can also kickstart your application from your Visual Studio, so you don't need to remote in and manually run it. but it's experimental. They haven't finished that part yet. So it gives you all the instructions on how to set it up. I didn't have time to go over it. But then when you get it to run, then you just basically once you go and you deploy your application, you just need to remote in, and you do .NET, and you select your DLL of your project name in this case, and then that will run your application like so. And then it'll show you that hello world message that I showed you earlier. It's really cool. It's really handy once you get it working, but there's a little bit of plumbing that you need to get it to work. We're a little bit over the hour, but I'm just going to show you just the Windows version, the Windows getting started, and then if you have any questions or comments, please write it out, and I can answer them as best I can. I hope you're enjoying or getting a gist about how things work with this new doc site and new getting started templates. So yeah, let's go to the Windows one. So same deal, same standard things. You need the .NET Runtime, Visual Studio. I don't think you actually need, well, yes, you will need the Visual Studio extension for Meadow because it'll install the templates. And so that way, when you get the templates, you can actually create a Meadow application. So let's do that. Let's go to our live demos projects. Let's do add a new project, and then Meadow here. Okay, here we go. And then we look for Meadow Windows app. Forms. Yeah, so this is very similar to what I showed you on Meadow Linux that had GTK display to show to use your existing graphics engine on your device to show Meadow running in there. So it's very similar to what we have here with Meadow Windows. So if we take a look at the NuGet packages, in this case, we have Meadow Windows. We have displays, which is the WinForms. It's just a regular WinForms window. And I also added the micro layout here. And if you see here, we have, this will be the structure of a Meadow Windows application. So we have a Meadow app, and we're specifying in what platform we're running. In this case, it's going to be Meadow.Windows. I think there was a namespace issue there, so we needed to prepend the Meadow namespace behind it. And in this case, we can't specify in which Windows device we're doing because we're not exposing pins for that. We'll need a different hardware you connect via USB-C, like the FT232, and that will expose you actual general I/O pins, so you can plug in devices there as well, and peripherals. So here we're doing a WinForms display. So when we create an object, we specify the resolution 320 by 240, which are again the same resolution we have for the project lab, and we pass in the display controller. And so here again, we're the same class that we looked all day. We have we get an iGraphics display, and then we have a display screen, which is display the color, and then finally a label, and shows a hello world message there. Now I think there's an issue with the WinForms NuGet package, but I think it's been fixed, but it's not in that version. So I'm gonna go ahead and go to the include pre-release, because that one does include that fix. So I'm going to update this. Graphics layout. and Meadow windows as well. Okay, and I think there's going to be an API breaking change here, because we're renaming iGraphics display into iPixel display. We'll add that into our release notes. I'll change here for the keyword of the contracts, and I think that's it. If I build this, there we go. So I set up as start a project, Hello Informs. I click play. Hopefully this will work. There we go. So it'll open my terminal to show me all the strings, and then there's also my little display here. It gets smaller as the display resolution gets bigger. So yeah, this is the hello world message here. So if you want to take a look at using the Meadow stack, yeah, make sure to check the Meadow Windows one. And we also have, I think I added a section for, this is the section for the FT232. So you can plug this directly onto your Windows machine, and then you can do things like connect an LED or connect a display, and or any sensors, and then you would just use it as you would be making a Meadow application. You just specify which pins are connected, and then you're good to go. And so that's basically what this template does. It just shows you an RGB LED blinking and changing colors, along with a little display that I showed you earlier. And we also have a Meadow desktop samples repo as well. So if we go here, there's the pinout, very useful when you're planning on plugging things onto your device. Let me move this here. And then we also have some samples here that are ready to build and run. And we have a Meadow Linux sample section as well. It's a little lonely. I think we need to add a little bit more samples in there. But this is all very new. The templates are also pretty new, so I think we can start ramping up and adding more Meadow Linux Raspberry Pi templates here, projects, samples, and that's pretty much it of what I wanted to show you. Is there any questions? We can go also here, before I forget, we also have a Meadow Cloud Getting Started section as well. So you need to sign up to have a Wilderness Labs account here in order to continue to use Meadow Cloud. And then it'll walk you through provisioning a device, so you can orchestrate, like you can add your devices into your Meadow Cloud account. So if I go to, let me see, I'll show you real quick here. If you go to your Meadow Cloud and then you provision devices, they're going to show up in this devices section. And then here you can do things like over-the-air updates, or you can see device logs, health metrics. In this case, in this getting started, I'm walking through the process of using the health metric system. So a feature which lets you send telemetry data on your display of your device into Meadow Cloud. So it'll show you things like, if you can see here, let me zoom in. Can I zoom in? The new tab there. So yeah, you can see things as the temperature of the CPU. You can see what kind of version of the OS you're running, how many disk memory you're using, or just flash memory. Battery percentage, if you have battery hooked onto your device as well, it would give you the voltage, or in this case, a percentage. and a health memory used. I mean, this is just the RAM memory that is being used, and you can send that periodically. So the getting started will get you to get this working. And so once you start seeing these logs onto MetaCloud, then you have successfully configured all this. And then if you go to the MetaCloud section here, this will give you a little bit of more features and more services that you can use. Sorry, in this case, you can do things like over-the-air updates as well. So you can listen for updates available, and you can also apply the updates, the apps that you're sending over the air. And this is the way that we use to package a project. So when you package it, you upload it into your MetaCloud, so they'll show up in here. And then you do publish, and when you do publish, it's going to send it over to all your devices or a collection of devices that are already connected or are in production. And so it'll pick up that update, it'll download the application or the OS even, and then it'll automatically just flash itself and apply the updated app, and then it will restart by itself. So if you have apps in places like in a garage or something to control your garage gate, you don't have to go with your computer and plug that in. You can just do it all from here, which is pretty cool. And we also have access to integrations as well. So as I mentioned before, you can use webhooks, Azure Event Grids, Event Hubs, DataCake. So you can add all that into your dashboards for enterprise solutions. Ralph Gomez says, hi. Hello, Ralph. So yeah, we have lots of things here in material to get you set up and running. Again, the free tier gives you more than enough access to all these things, and you can get familiar with the platform. And we also have hardware tutorials. Brian has been working really hard on getting these tutorials. They give us really good results on Google, so a lot of traffic goes in here thanks to these tutorials. So they're really fun to follow along, and they're nice to get you started a little bit thinking about in IoT terms and building your applications. It's important to know these things. Perhaps says, what is this? This is the Meadow walkthrough. This is a Willow Steps walkthrough on our website. This is hardware tutorials. So I'm walking you through hardware tutorial sections here. And also we have the API docs have also been revamped as well. So if we do say, if we add audio, well, I think I have something more. Peripherals library, yes. So here we'll see all the different peripherals that are available on Meta Foundation. So if I open the radio, for example, this will show you a little bit of a blurb of what the peripheral looks like. There's also the source code of the driver itself. We have access to the data sheet, and it gives you a status that if it's live and it's working, along with a code sample. And it has 13 diagrams too, so you can see how you can wire up your peripherals onto your Meta device. And so if you wire it like in the diagram and you run this code sample, it should do something, so you can see the usage of how all these peripherals work. So yeah, there's I think 200 peripherals in our list. So there's a lot here. Displays, lots of displays. We have I/O expanders. There's a lot. Yeah, there's servos here. There's buttons. There's LED controllers as well. You can have LED strips, motors, stepper motors. Yeah, and lots of sensors, atmospheric sensors and camera drivers as well. So there's a lot here to go on. But you can just get started with our getting started section to just dip your toes into it and then try Meta Foundation and try all our samples and yeah, enjoy building Meta apps. So that's what I wanted to show you today. Thank you all for tuning in, and I'll see you next time. Cheers.